Welcome to another Making Saturdays Awesome. What you can see on the table here in front of me are examples of what it is that we're going to build, but we'll get to that in just a second. One of the important pieces of human endeavors is the ability to take work that we do with our bodies and translate that into other kinds of work. Now, it winds up being with the invention of the internal combustion engine, along with harnessing animal power, where we get the term horsepower from. Before that, we were using things that weren't as efficient and also came with an incredible amount of suffering. That's more of a history class than a mechanical STEM-focused class, but it's important to know. Something to look into. Anyway, one of the things that we did long in our past to harness the amount of energy that a human is able to produce is build first simple machines, things like ramps, levers, pulleys, which we'll wind up using all of, I'm sure, over the course of this program. Taking simple machines and then linking them together to give us what is therefore called a complex machine is one of the ways that we have edited the world around us. What I'm talking about is the fact that what a human can do as we push or pull or spin something, that's good, useful, but it winds up being not the most efficient way of doing something if we can combine this process, pushing, pulling, twisting, with a bit of human cleverness. If we can, what we get are all sorts of fascinating ways of interacting with the universe. One of them is the ability to take rotational movement, and I am bending that rotational movement that I'm creating with my hand around 90 degrees. You see that the interface of these two gears is a 90-degree angle, and so I am spinning this stick in this direction along this axis, but I'm getting movement as if I were spinning this at this angle. This is an incredibly important piece of human technology and the way that we are then able to interact with the world, because if you have to interface with a device that you want it to move, say, underwater like this, but you don't want to have to be underwater to get that movement in that direction, you can have this sticking up out of the water, and then you just move this one and you get that movement underneath the water. An abstract example, but that's kind of the point, is that it is the application of human cleverness with these ideas that allow us to do all sorts of fascinating things. And anything in the world around you is really just a combination of several simple machines into a more complex machine to harness the properties of reality, the nature of our universe, the world around us, to do things that we want to do. So the ability to take movement at the human scale and make it either much, much bigger or much, much smaller in careful, predictable ways is one of the reasons that we care about complex machines, because it allows us to take what we're doing at this level and either zoom in really far or zoom out really far and still do usable, predictable work. Another opportunity that we get when we build complex machines is that we can make coordinated, simultaneous systems. Here, I spin this one middle peg and I get spinning movement out of both of the pieces sticking vertically. If you'll notice though, interestingly, this one is moving a lot faster than this one is. I wonder why that might be. I do not wonder why that might be. I built it that way. I hope that you wonder why that might be and how to get it to do that in a way that you want to see predictably. Let's talk a second about gears and why they are fascinating. The interesting feature about them, as you can hopefully see here, is that with the teeth they interface with one another in a very regular fashion. Every time this steps forward one tooth, it steps forward the other one tooth. Now, all of these gears are the same size. I cut all three of them using the same file. When I spin the base one rotation, this also spins one rotation. But that doesn't have to be the case. As we noticed with this one, we can get different speeds. And as you see in my build, it is because there are different size gears. Those are not exactly gears, but because of the friction between the pieces of foam, it works pretty similar to a gear. The reason we're not going to be using the gears in this particular project is because foam is a really good analog for understanding how the gears are going to function, and were we to just give you the gears, that portion would be pre-built for you instead of you working through how to build the circles or squares, triangles, whatever it is that you decide to use, and why you might want to use particular shapes over others. Also, this is just much more highly editable, whereas the wooden gears in this are more difficult to make different. And I am all in favor, in general, and in particular in this program, for the opportunity to just make things the way that it should be, that you want it to be. We'll set aside that one, and we will take a look at this one. You see that there's a little bit of wobble in all of the pieces. That's okay. We can make this better. Hopefully, you are interested in figuring out how to make it better. Luckily, we gave you enough foam that you could make several sets of gears and figure out interesting ways to get them to work together. Let's look at the set of materials. You have some straws, there will be a couple of dowels, there's the craft foam, and this strip of cardboard will be made into the box to keep everything stable and in good relation to one another. To begin with, we need to build that box. Hot glue is going to be useful to you here so that we can make sure that things don't move around too much. I'm going to use my ruler with a pencil. I'm gonna mark out 4 inches here to here. You see that I'm not marking at the end of the ruler because that's not how this ruler works. Move down to that mark, mark out 4 inches, that mark, another 4, that mark, and another 4. We have a little bit more left over. That'll probably be good because who knows if my measurements were perfectly accurate, and maybe we just want some wiggle room there. Oh, actually I'm gonna use my ruler to make these bends nice and tight by just kind of pressing down into them. Boom, boom, boom. And then we've got a little flap to add some glue onto. In fact, we could just use that to glue down and make sure that it's pretty stable, but as you notice, these are pretty wobbly like this right now. So we're going to add in a little bit of structural integrity to this box shape by taking that tab that we know now that we don't need, and we know that because this is called dry fitting. I fit it to make sure without putting any glue or fasteners in. We know after the dry fit that this extra little tab we don't really need. I'm not going to cut all of it off. I'm not cutting on the fold line. Instead, I'm cutting just above it so that there's a little bit of space for glue to be popped onto. But as you see in these builds, there are little extra pieces, triangles in the corners, and that keeps it from being able to be crushed very easily side to side. Where those come from is this extra little tab, and you just go corner to corner like this and get 2 triangles out of it. And in just a second, we will add those into our build. We take this, and we know that we need glue right there, so pop some glue in and touch it down. This one is a little wobbly right now, and we don't want that. Once that is glued nicely there, I'm going to add a piece onto 2 opposing corners. That gives the most amount of structural integrity that we can get. Another spot that dry fitting is helpful. We now have an idea of where the glue needs to go. We don't need to put it all along the entire bottom. We can take our pencil and make little marks just on the inside or outside. And then when I go to lay the glue down, I have a mark there and a mark there, and I know that that is the only space that I need to glue. Try to hold this at a nice 90-degree, 4 90-degree angles as you put this down. That will sort of be helped if you cut that square off appropriately to begin with, because if you line up the side with the side, it'll be pretty close. I'm gonna do the same thing on the other corner with a different strategy. Instead of putting the glue down there, I'm just gonna put the glue on here. Again, this is a way of making sure that it is using the right amount of glue that will hold nicely. The function of the straw is to keep this piece vertical and also give it a registration, but also give it something that it can slide with it so that it's not tight in the cardboard. If we were to put it through the cardboard like this one is, you can see that you can just spin the whole thing like that, whereas with this one, it spins much more freely. So we're going to create this piece right now and then mount it in the top. How long that piece needs to be? Figure it out. It has to be long enough that it goes through here and hopefully provide some stability on either side. My piece is 2 1/8. To make the hole in the center here, doing is just holding my hand very stably and then making marks from either side of the cardboard. And what we see is we get this nice line that has between it, that is the center. It is definitely something that you can eyeball here. Not a huge deal if it doesn't work out. I know that this is about the center in this direction. You could do the same thing here, but that's kind of a stretch to do that again. So another option is to take a ruler 2 inches and then using that mark and aligning it to the center of this, you just very carefully, without putting your finger right underneath the pencil, poke that through, and then use the pencil. You want to support it so that it doesn't bend like mine just did. Open that hole up a bit, and then keep testing it with your straw piece that I had you cut off to make sure that you don't make it so big that the straw piece falls right through. Great. Now that you have the straw put through the hole you made with your pencil, hopefully very carefully, we're gonna just make it so that it doesn't slide as easily. And also, just in case the hole was off in the angle at all, we can help that right now. So what we do is carefully, you wanna hold this near the top, and then you take your glue gun and you put a little drop of glue right there. And then you just let it sit. During the brush-bot maze, I call this tacking. It's the same idea. You're just putting a little helper piece there. Not really locking it down just yet, but making it so that you can then get underneath and put more glue under here if you feel that it might be necessary. With the amount that I play with these things after I make them, I think you should. And make sure that you get the glue touching both the straw as well as the cardboard. Once that is on, you can come back and if you feel you need to, you can add more on top. The function of that is to keep this upright, but we see that we're gonna have to cut this to be the right length. We will do that in just a sec. First though, we need a couple of circles. Your build kit has come pre-installed with a couple of circles. You can use this to trace out the internal circle and an external circle. If you want a smaller circle, you can use the inside of this one. If you want a larger circle for some reason, to try that out. That said, whatever circle you decide to use, you take it, lay it down on your craft foam, preferably close to the corner so that you can get as much use out of this piece of foam as possible. So you can try different sizes, things like that. But you just lay it down and then while holding it pretty firmly down with downward pressure, my circle is, okay. I'm gonna trace out my second gear. I'm gonna make sure that I can't see any of the circle that I just drew through this circle, and then give it a little bit more room so that I can get the scissors or whatever in there, pull the same trick, reach down inside, make a circle. Great. Now, I'm going to somewhat carefully, hopefully, slice out these circles to be my gears. But you see that what I'm doing here is I am not curving my scissors around, I'm just taking little snips and making a bunch of straight lines. That is, for the most part, good enough for our purposes. I'm gonna make this one just a little bit bigger than what I traced out. Pretty close, not bad. Awesome. Okay, you look at it from the side I drew on, and then here's the other side. Looking at it from the other side and then averaging out your mistakes, because you will always make mistakes, you will wind up making something a little bit better. It's not about not making mistakes, but being able to hide your crimes. 2 vague circles. Lovely. As you see from this one, we're going to mount the small one on what is called the drive axle. That's because it is the one that is being driven and drives the movement. To do that, we're gonna take this and mount that right in the center. We're not going to glue it though. Instead, we're going to make a little hole. To make that hole, you can use lots of different strategies. One of them is you take all of your scrap, lay that circle on top of your scrap, find the center of the circle by just eyeballing it, or you can measure and then push your pencil into that, flip it over, still on the scrap material, push your pencil into it, and that's pretty good. That's enough to be able to get this to poke through. Boom. Nice. So now we have the center axle with our gear piece of foam on there. I'm gonna take this back off. What I was doing there is dry fitting. Remember that term from earlier? But because that is going to have to be inside here and the skewer goes through both sides, what I will have to do is put the skewer through and then through here and then out the other side. Before we put that one on, we need to have some idea of where this one is going to drop to. Same idea, some scrap material just so I'm not jamming the pencil down into the table, and then I put it more or less in the center, push it down through, flip it over, just widen that hole a little bit, and then make sure that it fits again on our dowel. It does. Lovely. This one, as we see, is going to sit down inside. And so what we're going to do there is drop this through and then mount it up down here. Before we do that though, we're gonna dry fit to see about how long we want this dowel to be. So let's just make it that long. How long is that? I don't know. I'm gonna check. That is 4.5 inches. If you want yours to be 4.25, do that. If you'd like 5, that's fine. This process right here, it can be this piece, because I'm holding this one stable, this piece might go flying. And so there are a couple of ways that you can do this. If you're working on your own, then you can kind of angle it down into this. You'd also angle it inside of here. This is probably the one that I prefer so that you know exactly where it's gonna go. And here's my piece. Thread this down through here, and then we drop it through the circle center there. And now we have another concern, which is it can right now drop all the way through. You can see that I didn't think of that when I built this one. The weight of this entire thing is sitting there. There's nothing holding it from doing that. For my purposes, I'm going to add that now because that helps with the building of the next step to know exactly how high it's going to be. I take this, I raise it up so that this piece is more or less in the center. I tape this only around the skewer, not around this, but I do make it so that it sticks out from it, like a little flag. And that way, it can only go down so far. I would encourage you to experiment with taping so that it can move freely, but doesn't drop down too far. Now that we have that, we take this and now we're just kind of testing it. We want it to be about like that, and so now we can see where on our frame we need to make that mark so that we can put holes through for this one. I just rubbed it a little bit so that I would have an idea, but it looks like that is 2 inches up. Great, so halfway. Done a pretty good job of getting the halfway mark. I'm gonna measure up here 2 inches and then carefully make another hole. This one I'm not gonna make as large because we're not going to be adding the straw to this, but we do need 2, whereas previously we only needed the 1. Here I'm gonna measure up 2 inches. And now you very carefully, without putting your finger directly underneath, or else you will stab yourself like someone that I know just did. So don't do that. Thread this carefully through one side, put our piece of foam on, get this through the other side as well. Spinning it while you push will help you position this underneath this other piece of foam. Here I'm just gonna use a piece of electrical tape and just make a little flag. As I spin this bottom one, I am changing rotational motion in this axis into rotational motion in this axis. Forward and backward. When I am rotating it like this, and this gear is on this side of the large gear, it spins in that direction. But as I push it through, at some point, it just flips directions and starts going the other way. Why? It is honestly fascinating, the number of things, the complicated nature of the behavior that you can get out of something like this. I hope that this is fascinating stuff to your mind. I have enjoyed doing this. Looking forward to seeing what it is that you build, and seeing you next week for another Making Saturdays Awesome.